In stats, we started chapter 5, probability. So some basic rules. Probability of any outcome must fall between 0 and 1. And next is law of large numbers. So this is the most basic form of probability, and a good example is flipping a coin, because getting heads or tails is 50-50. So what happens if I flip a coin a few times versus many times? If I flip a coin a few times, let's say just 20 times, I could get a disproportionate amount of heads to tails. And you see that it's fluctuating all over the place. After 20 flips, we are at 40-something% heads. Whereas look what happens when we flip it 500 times. It is getting really, really close to 0.5. And this is called the law of large numbers. The more times you do a chance process, the more it's going to approach the true value. So, a computer program was able to simulate this for us. And a simulation is what we have to be prepared for on the AP test, because many times they ask us to do a simulation. You also have to know how to interpret a probability or a proportion. And one phrase you can use is in the long run. Or you could say, if done many times. We can expect the proportion of heads to be about 0.5. I think I should add the word about, because it's never going to be exact 0.5 or 50%. All right, moving on. We have a simulation to conduct. So maybe hit pause and skim through this paragraph. So in this scenario, I'm going to zoom in a little bit because I need to mark on that random number table you see at the bottom. But in this scenario, we have 95 students that are in this lottery, and 28 students are in AP Stat class, which are in that group of 95. A lottery is done. They drew 2 names, and they happen to be 2 of the 28 from Stat class. So it looks a little mysterious. Maybe they're all friends, the person that selected the 2 people. And we want to determine if it was done fairly with a simulation. So I'm going to scroll up past this so we can read the table, and we're going to write out how we should respond. So the way to begin this is restate the question. Did the results of the parking let's change did to were. Were the results of the parking lottery legitimate? Or were they manipulated? Was it done fairly? I should have probably just said that, but I wanted context. So the way this is presented many times is they give you a random number table, and you need to know how to use it for the simulation, because they force you to get full credit to use a random number table. You could use a random number generator, which is basically what this is. It's just outputting random numbers between 0 and 9. These breaks that you see right here mean nothing. So those breaks, that's just to make it a little easier to read. I typed this up and I put breaks in it because every random number table I've seen has breaks in it. So it may not look that way on the test, but I bet it will. So first you need to number students 1 to 95 with the random number table. Let corresponding students be 0, 1 to 95. The reason is because if I only go one number at a time, no two-digit student number, for example, student number 15, could be selected. So if I'm going left to right, reading this thing, first student would be 3, second student would be 5, next student would be 4. I am never going to get a two-digit number. So you have to force yourself to get two-digit numbers by saying this right here. Because if you think about it, 0, 1 is just as likely to be outputted as, say, 95. You need to ignore numbers out of that frame. So ignore 96, 97, 98, 99, and 00. You could just say 96 to 00. Select 2 students to represent 1 trial. Ignore repeats within a trial. It is completely up to the person that types this up how many times you do it. For the sake of time, let's do it 20 times. Simulate 20 times. I think in first period we started to do it 24 times, and I didn't even have this printed. It was very tedious, but usually this will be pre-printed for you and you just mark on it. So if you were confused, oh, I'm forgetting one thing. Who are the stat students? Let 0, 1 to 28 resemble AP Stat students. Okay, now we're ready. So you may still be confused, so please watch. And I hope this is large enough to see. So 35 is student number 1. 47 is student number 2, and that is trial 1. All right. 65 is student 1. 59 is student 2, and that is trial 2. So all you do is you mark on the table and number the trials. And that's it. So trial number 4, we got student 42 and student 16. Trial 5, we get student 58 and 50. It goes pretty quick when you've had this pre-printed. You do need to mark out if it's outside of the range of our sampling frame, 96 to 00, or within a trial if you have a repeat. So I'm going to hit pause, and suddenly the results will appear. All right, there are our 20 trials. You need to mark a few things. First off, look at trial 12, we got 99 in there, so I crossed it out and I picked the next two numbers. So that's important to note. The next thing important to note is anytime we get a stat student. So for example, on trial 1, I don't see one. Trial 2, I don't see one. Trial 4, I see a stat student right there. But we're looking for trials where we got 2 stat students. So let me change colors and lightly mark. We didn't get 2. So 35 is not a stat student. 47 is not a stat student, so that trial does not interest us. Trial 2 doesn't. Trial 3 doesn't, and so on. Even trial 4 doesn't interest us because we want 2 stat students. And look right here. It happened on trial 6. We got 2 stat students. Not that one, not that one. Almost right there. Ooh, again. So 2 times, 2 trials, however you want to write it, out of 20, we had 2 AP Stat students selected. So you have to ask yourself, is 2 out of 20 unusual? 2 divided by 20 is 0.1. And remember, we decided early in the year that 0.05 or less is rare or unlikely. 0.1 is greater than 0.05. This is not a rare proportion. In first period, we did 20 trials on another random number line, and we got 0 occurrences. That was very weird, because it really should be, I think, a touch, like if we did this for forever, indefinitely, it should be right under 10%. So I bet if we bumped up our trials to, say, 40, I bet we would have gotten some more occurrences. But you go with what they ask you to do, and you compare the result to 0.05. Since 0.1 is not rare, we're going to end up concluding that we do not suspect that the lottery was manipulated. We do not think the lottery was manipulated. These results could, let's make sure we get some context in there for the golden ticket parking lottery could have happened by chance. So, like, if I had gotten, we would have had a tough decision to make if we had gotten 1 out of the 20, because that's right on the decision point. In that case, I would just bump up the trials and keep doing it. And if you continue to not get any, and it's less than 5%, then I would say, yes, you suspect the lottery was manipulated. It was not done fairly. So you have to decide up front how many times you're going to do the process and compare the proportion of 0.05. If it's larger than 0.05, we're not shocked by results. If it's smaller than 0.05, we are shocked by results. And in this case, suspect manipulation, unfairness. Hope that made sense. See y'all later. Bye.